Hello, welcome to Maths with EJD. This is the second video on probability, and here I'll be considering coins and dice, probability with coins and dice. They serve as coins and dice serve as very good examples. When we talk about probability, because for instance, the toss of a coin is used, for instance, to determine who starts a match, or sometimes if you want to break a tie between two people, you can use that. Then dice too, you have that coming up in a lot of games, like snakes and ladders, Ludo, and all of those kind of games. So you can actually, with this knowledge of probability, you can actually, bring some math thing into whatever game you're playing. So that's why I think it's special. It's important I talk about probability, talking about coins and dice. First of all, let's start with rolling, or let's say tossing a coin, since we're starting with coins first. So let's talk about tossing a coin. Tossing a coin. So of course, a coin has two sides, generally head and tail, but then that's a fair coin. Okay, yeah, let's not worry about fair coin or not. When we get to that, to talk about fairness and unfairness or biasedness. So tossing a coin, right? Generally speaking, you know that a coin has a side where you have, the someone's head. I don't know. I'm not very good at drawing, but let me just try. You have this, you know. So this is actually the head, and then the other side is actually the tail. So every coin has a head and a tail. Okay. So when you toss a coin, right, the sample space, the sample space when you toss a coin is just either head or tail, basically. And here, if you're asking question, what is the probability that when you toss a coin, what's the probability that when you toss a coin, you get a head? That's simply one out of a total of two. So the number of favorable outcome or number of possible heads you can have is one, and total possibilities you can have is just two. So that's that. So that's for tossing a coin. But you can actually take it further, right? And talk about tossing two coins. Okay. When you toss two coins, the dynamic changes a little bit. Now here you see, okay, let's even go first. So you have coin one with head and tail, and you have coin two with head and tail too. So it means that the first coin, so this is like coin one, everything here is coin one, and then you have coin two. So so the possible outcomes can actually be something like this. So the first coin can show up with a head and the second a head. First coin head, second coin tail. First coin can be tail and the second coin is head. First coin can be tail and the second one will be tail. So with this now, you have four. So your sample space is actually this: head, 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 tail, tail, head, and tail, tail. So here you have four outcomes. So can you see a pattern already? So when you have two coins, when you had two coins, I mean, sorry, when you had a coin, when you had one coin, so the outcome is 2 raised to power 1. So that is 2, right? That simply means the faces, the number of faces the coin has, raised to the power of number of coins, okay? Number of coins. So that determines the number of outcomes. So here too, you have two faces for a coin, raised to power 2 coins, and then you have 4 outcomes. So you can know the number of outcomes you're going to have based on the number of coins you have, because every coin has 2 faces. So with this sample space now, you can have questions like, what is the probability of having zero head? If it says zero head, that means no head at all. That means this, all tails. Zero head means all tail. That means you have 1/4, because there's only one situation where there's no head at all in the on the two coins. Now, it's also important to understand that tossing two coins is the same thing as tossing a coin twice. Tossing a coin twice, it's the same result. So if you toss two coins, or you toss a coin twice, it's the same result. So the first toss can give you a head, while the second gives you a tail, and all that. It can give you all those possibilities, in short. So now, What if you're interested in the probability that in the when you make the two tosses or when you toss the two coins, you are going to get just one head. So in which cases do you have just one head? So HT and TH, those are the two cases where you have only one head. That'll be 2 out of 4, and that will be 1/2. So you have 50-50 chance of getting only one head or only one tail. Now, what is probability that you get two heads? Probability that you get two heads. There's only one case where you have two heads. That's 1/4 again. Okay. So all of that goes. So you can actually make, I think, what is called a probability density function or something like that. We're going to get to that. When we get to that, we'll talk about it fully. But for now, let's just stick with what we have. So you can also get a question like you want to find the probability of getting at least, at least one head. At least one head. That means probability that you have greater than or equal to one head. You understand? That means at least one head means minimum of one head. That means you can have greater than or equal to one head. That's probability one head plus probability two heads plus probability three heads. That's what that simply means. So in that case, everything goes. Probability one head, that is 1, 2. Probability two heads. Okay. So we can go up to three heads, sorry. Okay, so this can be there because we have just two coins. So probability one head, these are the two situations. Probability two heads, it's this one. So probability one head is actually 2/4. Probability two heads is only 1/4. And if you put everything together, that's 3/4. So that is when you toss two coins. When you toss two coins, or when you toss a coin twice. Now, we can extend it to the possibility of tossing three coins. How about if we tossing tossing three coins, which is equivalent to tossing a coin thrice, tossing a coin three times, tossing a coin thrice. So that's another situation. In this case, it may actually not be possible to make a table, but if you see what has happened before, when we tossed a coin, we just had head and tail. Those are the possibilities. But when you toss two coins, right, there's a way to go. You can have tail, head, tail. And then at the next level, you can have head, head. You can have head, tail, tail. So that way you get this whole sample space. So you have a systematic way of going. So at first you have head, tail, and then next you have head, tail, tail. And then if you need to toss if you need to toss three coins now, since you may not be able to draw a table, and if you try to just just write it down, you may miss it. First of all, it is important to know, oh, it has two faces. Now we have three coins. Okay. Say two faces raised to power 3, raised to power 3 coins. Okay. So that means you're going to have 8 outcomes. So since you already know you're going to have 8 outcomes, right? So you can follow this rule. Just write head, tail, head, tail, head, tail, head, tail. That's 8, right? Head, tail, head, tail. So if you toss the first coin, right? The first of the 3 coins can give you head, tail, head, tail, head, tail, head, tail. So next you go head, head, tail, tail, head, head, tail, tail. And then lastly, so you go alternating 1, 1. So next you go alternating 2, 2. Next you go alternating 4, 4. You go by 1, 2, 4 like that. So if you are tossing 4 coins, for instance, you go 1, 2, 2, 1, 1, 2, 2, 4, 4, 8, 8 like that. So here now we can have 4, 4. So that's head in 4 places and tail in 4 places. Head, 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 then tail, 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 tail. So this is simply our sample space when you toss 3 coins. Okay. So you can have all head, or you can have all tail and everything in between. So the questions can come. So what is the probability of getting 2 heads? So this is 1, 2, 3, and that's it. So that's 3 over 8. Probability of getting 2 heads is 3 over 8. Of course, we can even start with probability of getting 3 heads. Probability of getting 3 heads. Now, I'm not talking about tail because the probability of getting 3 heads is the same thing as probability of getting 3 tails. So anything you do for head is applicable to tail. The probability of getting 3 heads is just one situation here. That's 1 over 8. So probability of getting 2 heads is where this place is where you have 2 heads. So you have probability 2 heads. That's that. What about probability of getting 1 head, just 1 head? So that's so here, okay, let me color code that for easy understanding. So probability of getting 1 head, probability 1 head, right? So where do we have 1 head? Um, this and this, only 2 out of the 8. So that is 2 over 8, and that is 1/4, 1 over 4. That's the probability of getting 1 head. Then what about the probability of getting 0 head? Probability 0 head, no head at all. That means all tail. That's the only one case here. That's 1 over 8, like that. So you can also have situations like, what is the probability of getting head first? So we don't care if any other thing comes later, comes second. We just want head first. So in that case now, head first is simply this, where head is the first in 1, 2, 3, and 4. So that is 4 over 8, and that is 1 over 2. That's head first. Then what is the probability of, for instance, of getting, say, probability head first, head third? So the first and last, it will be head. So this is one case like that. Head first, head last. This is another case, head first, head last. So no other case. So that is just 2 over 8, and that is 1 over 4. So those are possible things you can get. So you can go on and on like that. So, but I mean, I just want to stretch. Let's stretch a bit and just talk about, I'll just do the sample space and move on from there. So what if you want to toss 4 coins? Tossing 4 coins. I want to toss 4 coins. So tossing 4 coins, which is equivalent to tossing a coin 4 times. Tossing a coin 4 times. So how does that go? Like I've told you already, you know that you have 2 faces. Sorry, 2 faces raised to power 4 coins. And that is 2 times 2 times 2 times. That's 2 raised to power 4, which is 16 outcomes. So it is important to know the number of outcomes you're going to get. So in case it's not complete, you can always be sure. So in this case now, the sample space will simply be, like I told you, you have 16 outcomes, right? So just write head, tail, tail until you get 16. That's head, tail, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So head, tail, 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 head, tail. So making 16. So next you go 2, 2, right? So you have head, head, tail, tail, head, head, tail, tail, head, head, tail, tail, head, head, tail, tail. So you have gone 1, 1. Now you've gone 2, 2. Next you're going 4, 4. So you have head, 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 tail, 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 head, 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 tail, 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 tail. And lastly, you've gone 1, then 2, 2, 4, 4. Now you go 8, 8. So head 8 times, tail 8 times. 1, 2. So head 8 times, right? So that's 1, 2, 3, 4, 5, 6, 7, 8 for head. Then for tail, another 8. 2, 3, 4, 5, 6, 7, and 8. So with this now, you have the sample space, when you toss 4 coins or when you toss a coin 4 times. So all the normal questions can now come. What is probability of getting a head first, getting all heads and things like that? So, but I won't go into all that. So that's that about tossing a coin. Let's go on to talk about rolling a die. Rolling a die. So rolling a die. In the case of a die, right? I like us to talk about two types of dice. That a fair die, a fair or unbiased die. That is the normal die, a fair or unbiased die. Then in this case, you have the usual sample space, say 1, 2, 3, 4, 5, 6. So it means the die has not been manipulated, it has not been twisted. So in this case, you can have the regular questions like what is the probability of getting of getting uh of getting four? You know, how many fours do you have? Just one out of six. That's the probability of getting a four. And what is probability of getting an odd number? What's the probability of getting an odd number like we did before? So that's simply the probability of getting either uh one or three or five. So that's simply three possibilities out of six. That is 1/2. Now, what is probability of getting a prime number? What is probability of getting a prime? You know, a prime number is a number that can only be divided by itself or one. Okay. And of course, one is not regarded as a prime number. So that is the probability of getting a number like 2, 3, or 5. Those are the possible prime numbers. That's 3/6, which is 1/2. Now, it gets tricky because people can easily forget. What is probability of getting a square? You know that the number when you roll a die, the number that shows up is actually a square. So what are the possible squares here? So of course, it's easy to just think the answer is 1/6. And because you can easily forget that one is a square, because a square is a number that you obtain by multiplying two numbers by themselves. So 1 times 1 gives you 1, then 2 times 2 gives you 4. So you have either 1 or 4. So this used to be a very trick question back then when I was in secondary school. So probability of getting a square, that means you are either going to get a 1 or a 4, and that is 2 out of 6, which is 1/3, right? So you can have all of this. Okay, so and that works for a fair or unbiased die, a die that has not been tampered with. But of course, you might be playing a game where a particular number, is really important. For instance, I know in the game of Ludo, or I mean, even in Snakes and Ladder, right? You want as high number as possible also, so you can move fast enough. So that brings us to the idea of unfair, unfair or biased die. Unfair or biased die. So let's assume that 6 is a very important number in the game you're playing. So, and then you have found a way of manipulating the die such that instead of having 1, 2, 3, 4, 5, 6, you now have you now have one, say 6. Instead of 2, you have 6. And then you have 3 so that people will not easily notice. Then you have your normal 4, and then you have 5, and then 6. So by changing 2 to 6, you have increased your chances of getting a 6, which is important for playing the game. So for instance, in the case of a fair die, right, probability of getting a 6 is simply 1/6 because you have only 1 6 here. But here now, the probability of getting a 6 has increased significantly. It has doubled. The probability of getting a 6 here is actually 2/6, which is 1/3. So you have a higher chance of getting a 6 with this biased die because you have manipulated it. So that way you can win the game cheating. I mean, that's a possibility to consider. So here now the dynamics just changes. So for instance, the probability of getting an even number, remember that here, probability that the number will be even that's the probability of getting 2, 4, and 6, which is 3/6, and that is 1/2. That's 50/50. But here, probability of getting an even number has been tampered with. That's probability of either getting. Okay, it has not well, it still remains because yeah, it still remains interestingly. So it's either 6/6. So it's still 3/6. It would have increased if you changed any of the odd numbers to 6 also. So Then what is the probability of getting of course, we've done the probability of getting a 6, which is 1 over 3. So what is probability of getting a 5? Of course, nothing has changed. That's simply 1 over 6. So, but basically, this is the key part that you have increased, because 6 is important, you have doubled your chances of getting a 6 by tampering with the die, okay? So let's move on to rolling 2 dice. Rolling 2 dice. Rolling 2 dice. And of course, that is equivalent to rolling a die twice. Rolling a die twice. So here, the standard treatment is to consider, so you have die 1 with its 1, 2, 3, 4. It's 1, 2, 3, 4, 5, and 6. And then there's die 2 here with its 1, 2, 3, 4, 5, 6. So the sample space for rolling 2 dice will simply be all this. So the first die can show 1 and the second is 1. So it can be 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. It can actually be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. It can be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. It can actually be the first showing 4, and the second is 1. So it can be 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. It can be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Then it can be 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So the sample space, of course, just like in the case of a coin, so you have 6 faces raised to power 2 dice. Of course, die is singular, die is singular, while dice, D-I-C-E, is plural. Okay. So that's why we are rolling 2 dice or rolling the die twice. So 6 faces raised to power 2 dice is simply 36 outcomes. And that is what we have under that table, 36 outcomes. Of course, you can do the normal uh okay, I mean 1, 2, 3, 4, 5. I mean that's a lot difficult, but I think this is fair. So 6 faces raised by 2 dice, that's 36 outcomes. So now you know your sample space. So basically, this is your sample. Everything here is your sample space. Um, let me see what I can do. Let's say, so this is your sample. Everything here is your sample space. Okay. Now, so the questions can begin to roll in. For instance, what is the probability? What is the probability of getting same numbers? That is, you have same numbers on the 2 faces, on the 2 dice, okay? So then you can check same number. It can be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So that's 1, 2, 3, 4, 5, 6. So probability of getting same number on the 2 faces of the dice will be 6 out of 36. That is 1 over 6. Now, what is the probability of getting, say, probability that the sum is is greater, the sum is greater than 10. That is when you add the numbers on the faces of the dice, the sum the addition is greater than 10. So you have to go scouting, right? Of course, it's easy to see. Here, you're going to get 12. This is 11, 11. This is 10, 10, 10. So, oh, some greater than 10, right? If you want some, okay, let's say greater than or equal to 10. Greater than, greater than or, or equal to 10. Okay. So one's probability that the sum of the 2 numbers on the faces of the dice is actually sum is greater than or equal to 10. So you want 10 and above. So that's probability greater than or equal to 10. So you want 10 upwards. So that means you have, so of course, this is 12, this is 11, this is 11, this is 10, this is 10, this is 10. Every other thing is below 10. So you just count that as 1, 2, 3, 4, 5, 6. Interesting. Still 6 over 36. And that is 1 over 6. That's the probability that the sum of the numbers on the faces of your die is greater than or equal to 10. Now, what is the probability? What is probability? What is the probability that you get what is probability that you get a sum of 7? Okay, a sum of 7. That is when you add the two numbers together, you're going to get 7. All right, so to get 7 now, so you need to look at all the possibilities of getting 7. That's 1 6 2 5 3 4 4 3 5 2 and 6 1. Any other chance to get 7? I doubt it. Yeah, that's all about that. That's 1 2 3 4 5 6. Oh, everything doesn't have to be 6. It's only that everything we're getting is 6 like that. So 6 over 36, that's 1 over 6 again. Let me look for something that is not 7. Mm, okay, maybe I should go into the realm of products. Um, so what is probability that you get a product, a product of a product of 12? That is when you multiply the two numbers, you get 12. So let's see. 12 can be 2 times 6 is 12. What else? 6 times 2 is also 12. 4 times 3, 4 times 3. I guess I want to uh okay. Let me color let me change something there. So 2 times 6 is 12. 6 times 2 is 12. 4 times 3 is 12. 3 times 4 is also 12. Would that be all? 12. 6 times 2, 4 times 3. Yeah, pretty much all that. So it means we have like 4. So 4 times 3, 3 times 4, 2 times 6, 6 times 2. Those are the possible things that can give us 12. So that means we have 4 out of 36. That's 4 over 36, which is 1 over 9. So you can have all kinds of questions arising from here. So you can have question about sum or difference or something. Okay, let me even say difference. What is probability? To get a difference of 1. A difference of 1. So, okay, let me use red again. So that I get a difference of 1. So 2 1, 1 2 2 1 will give you a difference of 1. Then 2 3 3 2 will give you a difference of 1. Then 4 3 3 4 will give you a difference of 1. 3 4, yeah, we've done 3 4 4 3. Then 5 5 4 5 4 4 5 will give you a difference of 1. Okay. That's leading to some confusion. I guess I have to change the marker altogether. So let me go changing that. Say we change this now to blue. Okay. So difference of 1, 1 2 2 1, 2 3 3 2, 3 4 4 3, 4 5 5 4, and that's it. Okay, well, we can still have 6 5, right? We can still have 6 5 5 6. So how many? Blue looks a lot like what we already have there, so it's difficult to see the difference. But let's see, we are looking at a difference of 1. So let me change the marker to say what we haven't we used before. Let me use this orange. Oh, okay, better this. So difference of 1, right? 2 1, 1 2, 3 2, 2 3, 4 3, 3 4, 5 4, 4 5, and of course 6 5, 5 6. 1 2 okay, that's 1 2 3 4 5 6 7 8 9 and 10. So the probability that you get a difference of 1 is 10 out of 36. That is 5 over 18. So that's probability that the difference between the two numbers will be 1. Okay. So and that's how far I'll go talking about probability with coins and dice. That's really useful. Okay. So thank you for staying on till this time. And if you have not subscribed, be sure to do that. And of course, hit the notification bell so you can always get alerted when a new video is released. And of course, remember to comment, like, and share so that more and more people can get to see this. See you next time. Bye.